All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have, as always, an amazing webinar on tap for you, and this is a great topic. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your question and answer tab there on your interface and submit your questions, and we will try to get to as many as we can near the end of today's webinar. We also have an interactive chat interface, so please utilize it. Chat us up, let us know what you think, and we welcome your comments throughout the webinar. And also at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is the main application security technologies to adopt in 2021. Our speaker today is Shiri Arad Ivtsan, who is the Director of Product at WhiteSource. Shiri, always a pleasure to see you. Thank you so much for joining me today.
Thank you. Thanks for the intro, Charlene.
All right, well, I'm going to put myself on mute, take myself off camera, and I'll see you on the question and answer side.
Thanks. So, as Charlene already mentioned, we have a great topic today. We are going to discuss the main application security technologies that you will need to adopt during 2021. But why is 2021 different? So I think that one of the main reasons that 2021 is going to be a little different is what we had in 2020. And the main thing is, as we all know, the COVID pandemic hit all of us. And most of us started working from home. When we work from home and we work remotely, first of all, our companies need to adjust to that. But after they do, and after we have all the great facilities to work from home, we are still exposed to things like network security and some issues that we didn't have before. So this was a great challenge in terms of how we think and deal with security in the organizational level. But there are some things that actually never change. And what we see throughout 2020 and all the statistics, we can actually see that some things didn't change. And the main thing that didn't change is how application security is the biggest threat. So before diving into that, let's understand what application security is all about. Application security actually refers to the way that we protect our application from any external attack. It can be privileged access, someone accessing our application without any permission. It can be in order to steal data, in order to steal credit cards, or maybe in order to harm our application. So after we understand why we need application security to defend from all that, I think that the main idea is to understand why applications are actually most vulnerable than other areas in terms of vulnerabilities. So I think that the main thing is just the attack surface, right? Applications are the face of everything. So this is where we can put the user inputs, websites, right? If we think of SaaS applications, even if we think of, our mobile application, this is the way that we interact with the software. The second thing is, as we know with security, it's all about the people. And the developers who actually write the code have a lot of ways to do things that we don't want them to do. So it's all about security training and making sure that the developers are actually trained to write secure code. So there are a lot of things that we need to protect in terms of the application. The attack surface, the surface that the hackers actually can harm us, is a lot higher than any other part of security and things that we need to defend in terms of the assets. So let's try and understand, do we actually take this into account? And what we're looking at right now is the fact that organizations are actually not spending enough on application security. And this is despite the high risk. So we know that the level of risk in applications, as you can see here, is actually the highest, right? Of, network, endpoint, data, and server. But there is a gap because we actually, in terms of annual spend, we can see from various reports, this specific one, that actually we spend a lot on defending the network, on securing the network, and even the endpoints and the data than we do on actually defending the application. So this is a very important thing to understand. And the main question is, why is it like that? And we try to answer this question. Of course, there is no one answer and there is no correct answer to this. But I think that the main reason for that is that it's easier to protect the network. So one of the things that you do in terms of protecting the network, you have sort of a very clear protocol, right? Firewalls have been there, I think, forever. It's, I think, more easy to set it up than to defend the data and the servers and the network than to actually defend the applications. In today's webinar, we are also going to speak about how we secure the applications, because I think that the main thing is that application security is such a broad term. We need to defend and to secure the containers and, the APIs, and we need to make sure that the open source code is secure. So other than like protecting network or endpoints or data, of course, without, it's very important to do those, but it's also important to understand the implications of not protecting your applications. So let's dive into that. And the main thing that we want to understand now is how we actually address vulnerabilities in enterprise applications. So of course, that if you are a small startup, defending or securing the application is a little easier. You have a small set of developers, probably the code base is a little smaller, and the processes are not that complex. Probably there are a lot of challenges when you are a startup, but adding new processes is something that is pretty easy. And in an enterprise company where you already have all kinds of processes in the software lifecycle, I think it's a lot harder to set new standards and to start securing something that is not secure today. The most important thing is that when we deal with application security, it actually needs to integrate to your lifecycle, to the software lifecycle. So this is the process where you actually develop an application, and this needs to be part of your day-to-day routines. So let's say API security. From the very first moment that you start designing the application, you need to take into account the security aspect of that. In terms of new architectures that you build, it's also very, very important. Of course, the functional part is the most important thing, but there is no risk that you can take in terms of security. So what we speak about today is sort of the structured way of how to build software applications with security as a very, very important consideration. And the key here is really to identify your existing software lifecycle, software development lifecycle, and integrate into that. So let's understand what are the top 3 AppSec technologies that you should adopt. And these are just 3 that we will mention here, and we will mention them as the main trends of application security during 2021. But those are not the only one, right? So there are a lot of different aspects to application security. One that is currently raising and keeps gaining popularity is the configuration management and securing your infrastructure as code. So if you're using, all kinds of DevOps tools or infra tools like Chef or Puppet or Terraform, it's also very important to secure those. So I just want to mention that these are aspects that we're not going to talk about today, but they are also very important. Today, we are going to go over these main three. So the first one is container security. And when we speak about containers, today it's gaining a lot of popularity in terms of Docker images, Docker containers. And what we understand now is that when already a few years ago, actually, people were starting to move to the cloud and breaking those very big applications like monolithic applications into microservices, there was just no other way than adopting the container technology. But with that, we also understand that there are some challenges, some specific challenges to containers that we need to understand and we need to secure. The second thing is software composition analysis. So today, and we will discuss it and we'll dive deeper into that, but around 60 to 80% of an average code base of any application is comprised of open source. And software composition analysis is actually understanding and securing that open source part of your application, which again is most of the application is actually open source. And the last thing that we will discuss is API security and how to secure our API calls to make sure that no user input or no problematic input is there. So let's start. And the first topic is, of course, container security. So whether or not you already adopted containers or maybe you are in the process of adopting containers, an important thing to mention and understand about container is it actually built based on the kernel, and you have something, whether if you're using Docker, so you have the Docker engine that actually allows us to use the container in different operating systems without changing it, which makes it a lot easier. The other thing that we need to understand is that the container is actually built from different layers. So as we can see here, there is a base image. In this example, it's Debian, as you can see here. And then we have all kinds of commands like, add Apache, add MySQL, copy commands, install all kind of things. And then we have, after that, we have the static image. We can actually run it as a container. And container is the runtime level. Why do we need container security? So again, understanding containers is very important. And despite the promise of you will have less overhead in terms of course, there are less system resources. As we mentioned, there is great compatibility between different operating systems. And of course, it's a lot more efficient. But in terms of the security, it tends to be extremely difficult because, as you can probably understand, a container can quite easily lead to another container. So if we have one container that is somehow being compromised, right? Someone could gain access to one container. Quite easily, they can gain access to other containers and maybe to the base image. And this is a very problematic situation. In addition to that, we as people who are just starting to adopt containers are not used to the fact that we have all kinds of container registries and orchestration platforms like Kubernetes, for example, or Docker Swarm, whatever that you guys are using. And we need to understand the security aspects in using each and every one of those. So moving on to what we need to understand about container security. First of all, we need to keep our containers lightweight. And by speaking about containers, I speak mostly about the operating system layer, or what we refer to as a base image. So the idea about Docker is that the operating system level is very, very lightweight, and we have a few ways to achieve that. So either you can use a base image that is already lightweight. For example, we have Google distroless images that Google is maintaining, and this is a great solution for a very lightweight base image. Another important thing is to also harden your base image. So if you took something that is external, maybe your organizational policy would be to actually add additional hardening to that base image. This is how you can reduce your attack surface, because this is how, when something is being compromised, you cannot gain access to more than you actually need in order to run the container. The next thing is using images only from trusted sources. And this is not the only time in this webinar where I'm going to discuss trusted sources. So, I mean, open source is great and public things are amazing. But as an organization, as a company, you basically need to understand that you need to make sure that everything you build your application from is something that you trust. So let's say Docker Hub is a public image registry. Anyone can basically add new images to Docker Hub, same as GitHub, same as other public places. You need to make sure that what you take is something that you validated, whether if it's with an external security tool or maybe you validated it yourself in some way. You need to understand that the developers are using images or code only from trusted sources. So this can be like a golden repository where you only have images that are sort of safe to use and are secure. What some tools and organizations do is they actually sign the image. So we have like a digital signature for each and every image. And then when we go to production, to Kubernetes or to any other orchestration tool, we make sure that this image is exactly the same and that the image wasn't changed before actually moving to production. This is another great way to understand that, okay, this image is actually secure and it came from a trusted source. The last thing is to never run as root. And this is also a very important aspect. By the way, not only in containers. I mean, perhaps this is obvious and I don't even have to mention it, but always protect the host by properly configuring your container. So this is more or less regarding, the maybe a little goes to the infrastructure as code security, but making sure that the configuration is actually protected. So these are the most important things that I can think of in terms of container security best practices. Feel free to add any questions if you have any, because this is most of the things that maybe like the highlights of container security. And of course, that in terms of container security, there are all kinds of things. Like we can discuss how to protect your Kubernetes and the orchestration level. We can discuss how to protect and scan your images. But if we need to, have 3 high-level rules, so those would be the rules. And now we go to software composition analysis. And this is actually my favorite because I see software composition analysis as sort of like the quick win in terms of how you secure your code. Because if we think of like why we need SCA, we already mentioned like most of the code today in any software is open source. 60, 70, 80% sometimes even more is actually built from open source. And the open source world, again, it's great. It's very convenient that I don't have to have my developers actually write things that are available out there and someone already invested time and effort in writing them. This is great, but it also has some risks. So first of all, for my own developers, I can do security training, and I can make sure that they know how to write secure code. But when it comes to like a library that I found in GitHub, I don't know who is the developer who wrote it. I don't know if he ever passed any security training and whether or not the code that he writes is actually secure. The other thing is that maybe that person is just nice and, contributing to the open source community, but we also find places where there is malicious code. So maybe the developer is just, not trained for security and he made a mistake and made something that is not secure. And now I have a vulnerability because I'm using that open source. But maybe also there was someone that actually wanted to steal credit cards, and he found a place like a library in GitHub that he can contribute to and added a malicious code there. So those are two options, and we need to understand that we need to protect the open source. So it's on us to make sure that it's secure. And what are the best practices? So I mentioned this as a quick win. The reason that I say that open source is quick win is not because it's not complex, but it's basically because, first of all, it's most of my code. And second of all, in terms of the security fixes, so most of the things will actually be resolved. Most of the vulnerabilities will be remediated by just upgrading to the latest version of the open source component, which means that if I am always up to date, I will be almost not exploitable. And this is a very important thing to understand. But because we live in the real world and most of us cannot sit all time and test new version of the open source component, we will sometimes be left behind. And then we have a few important things to do. So first of all, we need to detect. We need to scan our code for known open source vulnerabilities and make sure that we have a list of all the vulnerabilities that our application is exposed to. The next thing is auto-remediation. And auto-remediation is very important because what I want to do is, of course, I want to remediate all of my security vulnerabilities. But I cannot do that, of course. I cannot do that because in an average application, we have hundreds to thousands of open source security vulnerabilities. So we need to select which ones we want to actually remediate. And we need to prioritize those that first of all, they are the ones who actually can be exploited. And second, we need to understand what is the business impact of that security vulnerability. So this is a very important thing to understand. Like, how do you prioritize? You can prioritize based on, naive approaches, or like, the basic approaches like severity or CVSS score. You can prioritize based on, is there an easy fix or not? But then you can also prioritize based on whether this application is actually public facing, whether I have personal users information there. So those are all great ways to prioritize. And then we come to auto remediation, which basically means I'm not going to invest my developer time on finding which application they should upgrade to and performing the tests. In general, I want everything that can be automated, I want to automate it. So I don't want any manual work from my developers. I don't want to waste their time on manual things. And it's actually very important. So auto remediation can be, for example, opening an automated pull request in GitHub or GitLab or Bitbucket when there is a fix for a vulnerability. And when I open automatically the pull request, I can also automatically merge it and run some automated tests. And then I can say whether or not I want to upgrade it in staging or in production. But in order to do this, of course, you need to have proper tests in place, and your company needs to be very mature in terms of DevOps. So this is like the highest level of security that you can get to. Then we try to be aware of alert fatigue. So I mentioned like hundreds of, security vulnerabilities in an average code base. And we usually see users just overwhelmed by the amount of alerts they get. And we end up like either doing nothing, start ignoring this tool because it just gives me like thousands of security vulnerabilities. I am never going to remediate thousands of security vulnerabilities. And then we end up just, giving up in the first place. And this is a very bad situation to be in because first of all, you know that you are exposed, right? You know that you've scanned your code and you have a lot of alerts or vulnerabilities. And second of all, you do nothing about them. So we need to responsibly monitor those vulnerabilities. We need to prioritize. We need to make sure on what we need to take action and what can sort of be left for maybe a later stage. So I think we discussed most of it, but like we want to be able to avoid this alert fatigue and make sure that we don't have noise or things that we know that we are not going to fix. So first of all, the tool that you choose should of course have 0 false positives or the least amounts of false positives. We want to implement a security tool that will actually prioritize automatically the vulnerabilities for me, that I won't have to do it manually. And we want to be able to automate the process of actually remediating the things that I marked as most important or that the tool marked for me as top priority. Moving on to API security. And this is actually the third subject. And it's very, very important because recently it came to the news. Not really, we will discuss the SolarWinds attack, which was partially really supply chain security, which I'm also going to discuss. But part of it was really around the API part. So we can say, first of all, that this is the third subject that we discussed, and this is the least mature one of all the security aspects that we just discussed. So the challenge of API security is that it actually needs to address not only one part of the application. It actually needs to address both the client, but also the backend and also the network security risks, right? Because the API is also about the network. So today, most of the attention, as we've seen in one of the previous slides, goes to the network part. But when we define sort of like the API security strategy, if you define it for 2021 in your organization, what we would recommend is don't treat API security as a separate from like the entire application security world. Like it needs to be a part of that. We want to be able to sort of adopt this holistic approach where we focus on authenticating the identity and setting rate limits in order to make sure that no one actually uses our API in a bad way or in a way that we didn't intend it to be. So this is like most of the things that of like why you need it. And now we go to the SolarWinds data breach. So first of all, the SolarWinds data breach is mostly not about API security. Most of it is regarding supply chain risk. And supply chain, I'm going to just, speak briefly about what supply chain security is. So when we speak about supply chain is more or less everything. And when we speak of supply chain, what we recently heard around the news is things that you may have heard, like dependency confusion or maybe just malicious packages. So what we usually see is people naming malicious packages. So I would create like a package in GitHub and name it in a very similar name to something that is already there in GitHub and is very, very popular. And then I will try to make sure that it has enough forks, enough downloads to just make sure that the stats are okay. And then people will start downloading it. So this is a very risky situation because then it's not the original code. You don't control what it does. Someone other than the original maintainer is actually maintaining the code. So this is SolarWinds, and this is mostly about supply chain security. Specifically in SolarWinds, it was more about protecting the build environments, which is something that we're not going to touch upon today, but it's very important. Like if you have build servers, like you have CI/CD, you're working with Jenkins, we need to make sure that the credentials are in fact secure and that the network access to there is secure. So there are a lot of aspects around like the supply chain part. One of the things that, even though this was actually a supply chain attack, the SolarWinds Orion API also had an authentication bypass. So this means that the API has had highly privileged access to basically all platform components, and this was how the breach was actually done. So what should we do about API security? So first of all, we want to be able to adopt a holistic approach. And this is something that I briefly discussed. We want to make sure that API security is part of the full application security posture or strategy. And in order to achieve this, we need to make sure that we are protected in the entire ecosystem. So including like if you're working with, cloud like AWS or Google or IBM or whatever, you need to make sure that the cloud environment is secure. You need to make sure that if you're working multi-cloud, you need to make sure that the network there is secure and the APIs are secure. Hybrid environment, like part of it is on-prem and part of it is SaaS maybe. So we need to make sure that all of that is indeed secure, and also, of course, mobile security. So we need to approach this end-to-end approach, to adopt this end-to-end approach, because if we will be just ignoring one of those, it can lead to very risky situation. So sort of taking this wide view, right? Looking at the current architecture of the application, what I have in the cloud, what do I have on-prem, what is currently a mobile app, and trying to build this holistic approach for the entire security for the entire organization. The second thing is to focus on identity. And what we usually see is that hackers just frequently impersonate users, right? So as we know, APIs are becoming more and more popular. They are evolving more and more, and identity is representing basically people, but we do it using like encoded digital forms, right? We have tokens, we have, all kinds of secrets, and on the basic level, identity just means, confirming the information about user rights, about the origin. So making sure that if I am contacting the application with a specific token, it's actually me contacting the application and not someone else who had the option of like stealing my token or getting my token somewhere. So we need to make sure that if we have token-based application, we refresh them often, we do it based on the maturity model that we can see here, like the API security maturity model. And if we speak about the API maturity model, so level 3 is like the most secure API security level, and it basically means just centralizing trust using claims. Usually, we use either OAuth or we use OpenID Connect. And in order to verify the claim, we're actually requesting party to call the issuer. who actually returns, in fact, the data signed with a private key. So this is not a new approach, but if we adopt this approach for API, this is really the highest level of security that you can get. So the bottom line is that we need to make sure that users who say they are the users, they're not like malicious actors looking to penetrate the application or do something bad to the application. So this is the second thing. And the last thing is really monitor and set rate limits. So one of the best ways to secure the APIs is to watch what users are doing, understand how users are actually using my APIs, and understand the behavior of the users. And if we do it, we can surprisingly just understand when there is something suspicious, when the users are not doing what they usually do. And doing this is a known thing, and identifying sort of this suspicious behavior is a very important approach. Other than that, of course, we can, other than monitoring and setting and looking for problematic usage of the API, we can also set rate limits so that once there is, large access to the API, someone is just flooding the system with requests, maybe attempting to bring it down, maybe just attempting to steal data, we can just set rate limits and stop that person or that company from doing what it does. So we're getting towards the end of the presentation, and we have a few very important takeaways. So the first one is that I mentioned SCA, and I think SCA, again, is the best point to start with. So if you're not doing any of the three things that I mentioned, I mean, maybe you're not, or you're doing, but you're not doing good enough. You're not doing good enough on container security, you're not doing good enough on API, and maybe you're not doing at all SCA. Since software composition analysis and open source is like 80% of your code, and all the fixes are out there, it may be easier to just set this as a first stage, automate it, prioritize what you have, and then move to the next stage. Exposed APIs are basically the next big attack vectors for enterprises, right? We understood that more and more people are trying to attack the APIs, and this is a very, this is sort of like the loose chain that we have here. If we speak about DevOps and the way that we sort of release in small cycles and automate things, so those are more aligned with like how we want to run the business and how we see like, the users of our applications getting value. But we do see that security is sometimes left behind, and when we like release and we do those night builds and we make sure that we push to production all the time, sometimes when we do it like very, very fast, we sort of forget about security. And security organizations are usually sort of behind. They didn't adopt yet the DevOps approaches. Maybe the organization is different, but we see that there is some friction between security and running like DevOps approach. So we want to make sure that we incorporate security into DevOps and using DevSecOps approaches. The last thing is security as code. And this will become more and more common in the way that we actually protect applications during the life cycle. So this is a very important note. Like if we say that exposed API will be the next big attack vectors and the API breaches are making it into the headlines, we see that the pace of development is faster, and the security level of the applications just can't really change. We cannot compromise on security. because we want to release in, smaller cycles and give better value. So those are my main takeaways from this session. I know that we have our public chat, so I'll be reading your comments, and feel free to post Q&As if you have any questions that you would actually like to ask.
All right, great. We have gotten some great questions in so far, but there's plenty of time. If you have a question for Shiri, go ahead and use that chat or the question and answer tab on your interface and submit your questions. Let's take a look at the questions that have come in so far. Excuse me. First question here, Ajoy asks, I understand that WhiteSource is cloud-based. However, do you also offer on-prem option or for certain dedicated instances, perhaps?
Yes. So WhiteSource is cloud-based. It's SaaS-based. Like 95% of the users are using the SaaS version, but WhiteSource does offer dedicated instances in the cloud for customers who prefer that option. And we do have an on-premise option. However, not many customers actually choose that.
Okay. All right, great. Next question here from Casey. If we want to use WhiteSource in our Azure DevOps pipelines, it looks like your pricing page says container support starts at the Teams licensing level. Is this correct? The free version doesn't have or support containers?
Yes, that's correct. So our free version supports package-based applications. Like if you're using NPM, Maven, Gradle, and additional, I think 9 other packages. So the free version is great for you. Also, it's a great place to start from. But if you want to scan source code, like C, C++, if you want to scan containers, so definitely the Teams would be the best option for you.
All right. All right, great. Lots and lots of great questions coming in. But like I said before, there's plenty of time. I think we have, almost 15 minutes for question and answer period. So guys, get them on in. Come on. Let's see. Next question here. Excuse me. You spoke about a few different application security methods. What would you recommend to start with?
So I think I discussed it briefly, but I think that SCA would be the best place to start with. And if you're asking about where should you start in SCA, the answer would be in the place that's easiest for you. So we see a lot of our users and just SCA users in general starting from the build stage. So the build like CI/CD, whether you're using Jenkins, TeamCity, Travis CI, Circle CI, is a place where you already run some functional tests. And if you want to get started on, testing and scanning your application for open source security vulnerabilities, I think this would be the best approach.
Excellent. Excellent. Okay. Excuse me. I'm so sorry about that. Okay. Next question here. Let's see. Who would be the person in the organization who would start or drive a security process? Would it be the CTO or the CISO or IT maybe?
So that's a great question. And I think it's a question that a lot of organizations actually struggle with. So first of all, we need to understand who drives the security process today in the organization. So usually it will be the CISO, right? Chief Information Security Officer. This is the person who is responsible for security. But then we understand that the person who actually needs to remediate or fix the vulnerability are the developers, and they are their head. Maybe it's the head of R&D, maybe it's the CTO, VP of R&D who is responsible for that. And then we also have the IT department that sometimes just traditionally owns security in the organization. And we understand that the person who drives this should be the security together with the development organization. So they need to go sort of hand in hand and understand what are the requirements, what are the policies in terms of security, right? What is the organizational policy? what's important for the security person. Maybe it's a thorough research on all the security vulnerabilities. Maybe it's protecting important assets, right? We need to understand that. And then we need the CTO or the VP of R&D to be on board, because we want them to be aware and understand what they have to, what's their incentive from dealing with security. And today we understand that security is not, it's everyone's problem, right? From the basic developer to the CTO, it's everyone.
All right, let's see. Guys, come on, get those questions in. If you got a question for Shiri, there's plenty of time. Right now, we've actually asked you all the questions that have come in so far. So I'm going to leave it open and see if we do get any more questions in. Just a quick reminder to the audience that today's event has been recorded. So if you missed any or all of the presentation, or if you want to watch it again, you will have the opportunity to do so. We will be sending out an email after today's webinar that contains a link to access the webinar on demand. And the webinar is also going to be on the Security Boulevard website, so you can always go look for it there. You just go to securityboulevard.com/webinars, look in the on-demand section, and it should be right there waiting for you. Excuse me. Well, it looks like we are not getting any more questions in, Shiri. So I'm going to go ahead and leave it open. And why don't we go ahead and do the drawing for the $425 Amazon gift cards. And then if we have any stragglers come in, we can go ahead and address those. Okay, our 4 winners today. Excuse me, our first winner is Casey W. Congratulations, Casey. Our second winner today is Ajoy S. Congratulations, Ajoy. Our third winner today is Jose C. Congratulations, Jose. And our final winner today is Yuri M. G. Congratulations, Yuri. And so we'll be following up with all 4 of you via email to get your Amazon gift card over to you. So please check your inbox. Looks like maybe, yep, I think we are done with the question and answer period because we didn't get any more in. So with that, I do want to thank you, Shiri, for a great presentation, lots of great information. And I think it was useful on a number of different levels for folks in the organization. Really doesn't matter what your job title is. I mean, this is a topic that is important to everybody in the organization. So thank you very much for such an informative webinar presentation. It was great.
Thank you so much. Thanks for having me.
All right. I also want to thank the audience for joining me today. And this is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.